So today we're going to talk more specifically about atoms and what makes up an atom, and then discuss the types of properties that scientists will observe when they are trying to classify atoms into different types, which are the elements. So our definition of an atom is that it is the smallest particle of an element. You should remember from our other set of notes we've taken so far on matter that sometimes elements come in pairs, like hydrogen and oxygen and nitrogen. When we see them in the air, they usually come in twos. So the smallest particle of that pair is the atom, just a single element itself. And so just to give you some perspective on how small an atom is, there are 2,000 billion atoms of oxygen in just one drop of water. That is 2 with 21 zeros after it. So that is how many tiny little atoms there are in just one teeny tiny little drop of water. So that should give you an idea of just how small these things really are. So atoms are actually made up of 3 smaller particles that we can separate not through chemical or physical means, but through nuclear separation. And so you probably heard of them before. Protons carry a positive charge, so those P's go together. Neutrons carry no charge, so the way to remember that is that they are neutral. So if you ever have like friends that are in a disagreement and they're trying to get you to pick sides, if you are neutral, that means that you don't go from one side to another, you stay in the middle. So protons and neutrons come together and form the nucleus, which is the central part of the atom. So it's very dense, everything is packed in really tight. Finally, you have electrons, and they carry a negative charge, and they circle around the nucleus, kind of like rings around the outer planets. So the way they travel around the nucleus is in energy shells or orbitals. These are what the names are for the track that the electron might take. In a couple of weeks, we're going to talk specifically about how electrons move around the nucleus, because over the past century or so, scientists have made a lot of discoveries in terms of how they behave, and opinions have really changed a lot over the years. One thing that they do agree on is that each orbital, so each track, can only hold a certain amount of electrons. So if you think of an actual track around a football field and you try to cram as many people as you can on that track, eventually you're going to run out of room. So that's the same idea for the electron orbitals. So here's a little picture to give you an idea of what an atom looks like in its most basic form. The protons and neutrons are in the middle, the electrons circle around. So to give you an idea of their size in relative perspective to each other, protons and neutrons have about the same mass, so they have the same amount of matter that make up their bodies. Electrons are really small compared to them, so they're much smaller, and because of that, they're able to move a lot faster. So this picture, I really love it because it gives you a good idea of the comparison between the different types of particles that are in an atom. So if an electron weighed the same as a dime, so imagine holding a dime in one hand, a proton would be the same as a gallon of milk. So if you compared the mass of the two, you would tell that there's a huge difference. And this bottom part shows how neutrons and protons do almost have the same mass. Neutrons are a tiny bit more massive than the protons. So because of how much bigger the protons and neutrons are than the electrons, when we look at the whole atom itself, the protons and neutrons are responsible for the entire mass of the atom. The electrons are barely visible, they're barely making a difference in terms of the overall mass. So because of the fact that they are the ones that are spread out and they're the outermost part of the atom, they make up the atom's volume. That means it determines how much space the atom takes up because they're the ones circling around the nucleus. So just a reminder of the definition of an element. An element is a substance that cannot be broken down into any other substance by physical or chemical means. And again, we see them on the periodic table. So that's the way we've arranged them to be able to organize them based on their characteristics. And we're going to pretty much get sick of the periodic table in the second 9 weeks, to be honest, because we'll spend a lot of time studying it and figuring out why it's set up the way it is. But an element is basically a type of atom. So there are some properties of elements that scientists will observe in order to figure out where they should go on the periodic table and see how they relate to each other. So we have a list of some vocab words. Structure means the shape of the element. Hardness determines whether the element is hard or soft, so that's pretty obvious there. So is the color. You may have heard the word luster before. Luster refers to the shininess of an object, if that's even a word. So if you've ever heard of somebody like the shampoo commercials tell you can get lustrous hair, it's saying you can get really shiny hair. So if you've ever heard that before, you can attach it to this meaning. We've talked about density, and that relates to an element's heaviness. And then melting and boiling point, again, those are two obvious things. Melting point is when the element would melt. Boiling point is when it would boil. Then we have conductivity. Conductivity is the element's ability to allow electricity or heat to flow through it. So a lot of metals have this type of characteristic. Ductility is an interesting word you probably haven't seen before, and this means that an element is able to be drawn into a wire. Malleability is the ability to be pounded into a shape, and I've had students before tell me that the way they remember this one is, if you've ever heard of a mallet, that's like a hammer with a really thick head that you can beat metals into sheets. And so mallet has the same first 5 letters as malleability, so that's the way they remember it. It might help you too. Solubility, finally, is the ability to dissolve in water, and I think you probably heard of that before. A few of these websites listed here are what we're going to see when we do a project based on an element of your choice, where you're going to pretend to be the scientist that's researching the element and figuring out what characteristics it has. So you'll see these in the future. So just to go through some examples of actual properties you might see when you do your research on the element that you choose. I'm using potassium as an example, so when you do your project, potassium is off the list of things you can choose from. So sorry, but just to give you an idea of the things you might see, the structure of potassium is crystalline, so when potassium arranges itself with lots of different atoms, they arrange themselves in a crystal shape. It's also a hard metal, or sorry, soft, I can't read. It's a soft metal, so that means that it can easily be scratched. It's a silvery white color. It has good shine to it, so it is shiny luster. Its density is 862 thousandths grams per centimeters cubed, and because it's less than 1, that means it should be able to float in water. It is insoluble, so if it was in water, it would not dissolve. And then its melting point and boiling point are listed here in Celsius, which is the metric system. And then you see this weird number with a K behind it. That is what physicists used for their temperature scale. And we're going to actually talk about this scale in about February, and it's called Kelvin. So you don't really need to worry about it until then. It's just there for your information. But to give you some perspective in terms of what we know, potassium would not melt until the temperature got to 146 and 57 hundredths degrees Fahrenheit. So it'd have to be pretty hot. It'd have to be even hotter to boil. It would have to be up to 1,425 and 2/10 degrees Fahrenheit. Finally, some other examples of some properties you might come across when we're doing our project are conductivity. So one example of an element that is a really good conductor of electricity is nickel. Ductility, an example of that would be like copper. Many wires have copper involved in them because it easily is spread into a wire without becoming brittle or breaking. And finally, copper is a really good example for malleability too, because it can be pounded into sheets. Aluminum is also a good example of that. So when we do our project, you'll see a lot of these properties listed out, and your job will be to determine what those properties of your element are, and then convert that into a project, whether you want to make a wanted poster for your element, like it's a criminal, or if you want to make an advertisement, like you're trying to sell it, or you could write a discovery paper from the perspective of the scientist that discovered it, so you can put yourself in their shoes and pretend like you're the one that did it. So make sure that you do the video check when you're finished getting the notes on today's presentation, and come into class ready to go tomorrow, and we'll get ourselves set up for our project. You have a great afternoon.